the next very important operation is called joins in SQL, right? So let's take a real world problem and see why joins are important to start with, right? Imagine, and the purpose of joins itself, look at it this way, right? We have two tables. We have movies table and we have the movies underscore genres table. For every movie, the corresponding movie genre is on a completely different table. For example, if you look at this data, right? If I say describe movies, I have the movie ID, name, year, and rank score in the movies table. And I have the movie ID and genre in the movies underscore genres table, right? Now imagine if I want the movie name, imagine a world where I want the movie name and the movie genre, right? If I want this, how do I obtain it? Because this data is split between two tables, right? Some of the data is here, the name is here, and the genre is here. But the ID that you have here, is available even here, right? This ID that you have here is also available here. It's the same IDs. It is the movie ID here. Now somehow can I join these two tables, or can I combine these two tables? Can I somehow join or combine these two tables and obtain the data that I want? It seems like a very logical thing to do, right? So let's look at it this way, right? So let's see the query. Select m.name and g.genre from movies m. So m here is an alias to movies, right? This is a table alias, right? M here is an alias to movies. This is not a column alias. This is a table alias, right? Join. So I'll come to what join is, right? So what I'm saying here is I want to obtain from movies M. First, I want to join movies M with movie genres G, right? Again, G is a table alias to movie genres. Okay, let's look at how the tables are actually, right? It's better to draw the tables so that it's easier to understand, right? So my table M, which is my movies, has an ID column, has a name column, right? And some other columns here. Similarly, I have another table called movies underscore genres. Let's call that table G because that's the alias we're using, which has the movie ID, right? And the genre of the movie. Now, the way join works, the simple join, right? There are other variations of joins that we will discuss later. So what does this say? This says that you want to join the movies table with the genres table, right? You want to join. The on is a very important thing. On using what? How do you want to combine these two tables? How do you want to join these two tables? You want to join it by using wherever m.id is equal to g.movie ID. So for example, imagine I have an ID 1 here, some name, let's call it name 1, ID 2, name 2, right? So on and so forth. Here also, I could have ID 1, some genre 1, right? Of course, a movie can belong to multiple genres. So I could again have 1 and G2. I could have 3 and G3. I could again have 2 here with G2 and so on and so forth, right? So the way join works is, look at the condition that we are giving on the join. Look at the condition we are giving on the join. We are saying, right? We are saying that given an ID, you want to compute the movie.id with g.movie ID. Wherever they are same, you want to combine accordingly. So look at this. You have one N1, you have one G1. So these two can be combined because the movie ID, so the ID in the M table and the movie ID in G table are the same, right? So when you join both of them, what do you get? You get one N1, the rest of the columns here, the rest of the columns that you have here, you have the movie ID already taken care here, and you get your G1. This is the table that you would get by simply joining, right? Now what you're saying here is simple, right? Similarly, this is one row. This is one row. There will be a second row which says 1, N1, the rest of the elements, again G2. Because look at this. This row matches this row also. Just like the way it matched this row, it also matches this because m.id here is same as g.movie ID. Similarly, this row will not match with this, it will not match with this, it will not match with this, it will match with this. Because m.id here is same as g.movieid. Right? So in the output, what we'll get here is rows like this. 1 n1, rest of the columns g1, 1 n1 g2, 2 n2, rest of the columns g2, and so on and so forth. So after joining, what am I saying? See, I want to join. Here is the condition, right? I want to join based on this condition that m.id should be same as g.movieid. That is the condition on which I'm going to join my movies table M and movie genres table G. Join basically means combining two tables. And from the resultant table, I want to obtain the name, because the name is available in movies, and the genre from G. Right? Now here limit 20 basically says that I want to see only the top 20 rows at the end of all of this. Right? So let's read this in English. I want to print, or I want to obtain, the name and genre from a table that is constructed by combining or joining movies M and movie genres G such that m.id is equal to g.movieid. And in the whole resultant set, I only want to look at the top 20 rows. Right? That's how you read the SQL query in English. Right? It's always important to understand SQL queries in English. So if I run this, see, this is what I get. Okay, I have a movie called A Mayor, which is comedy. I have a movie called Arkadas, which falls in both drama, romance, and drama. Right? Because a movie can have multiple genres that it is associated with. Right? Very, very simple. This is how joins work. And joins are an extremely important part of all of databases, because this helps us combine data which is split across multiple tables. And we often split data. We often split data across multiple tables. And now to combine all of the data, join is a critical part, right? So this is called the simple join, right? Very simple. This is called a join. We'll learn about more joins in the next video also. This is also referred to as inner join. I'll tell you what outer join is in the next video. For now, just remember that this is called inner join. You'll understand why it's called inner join when we learn about outer joins. There is another concept called natural joins. Let me explain what it is. Very simple idea. Imagine I have a table T1. Imagine I have a table T1 with two columns, C1 and C2. And let's assume I have a table T2, right? Which also has, let's say, column 1, column 3, and column 4. Now C1 and C2 are the column names here. These are the actual column names, right? These are the column names. C1, C3, C4 are the column names. One thing you'll quickly notice is that the column names that we have here are exactly the same between these two tables. The column names are exactly the same. In the previous case, the movies table had ID as the column and the movie underscore genres table had movie ID as the column. Even though they contained the movie ID, the column names were different, right? Imagine if the column names were not different, but exactly the same. In such a case, right, I can combine these two tables or join these two tables very easily by just saying this. I can say, look at this, right? I can say select, star basically means all the columns from table 1 or T1, join T2. The moment I say T1 join T2, it automatically understands that T1 and T2 should be joined using these columns. This is automatically equivalent to saying T1.C1 is equal to T2.C1. Okay, it is equivalent to saying on, right? It is equivalent. This is equivalent to saying, you don't have to say on T1.C1 equals to T2.C1. That's implicitly understood because the column names are the same, right? So when the column names are the same, you can completely ignore this on condition here. And if you just write this, it will work. This is called as a natural join. It's called a natural join because naturally the tables T1 and T2 understand that here is a common column or a common set of columns on which I need to compare these elements and combine the tables using these common named column or columns, right? So this is one way of writing it. Okay, this is called a natural join because you're not explicitly stating the on condition like the way we have done it here, because there is a common column name, right? Very, very simple idea, right? You can also write this slightly differently by saying select star from T1 join T2 using C1. This is another way of stating the same thing. So these two are exactly the equivalent. If you're not sure, or if you want to be really careful, or if you want to clearly state that yes, the joining should happen using C1, if you want to clearly state that, okay, you can explicitly state that you want to select all the columns from T1 join T2, which should be joined using column 1. Okay, but both of them are equivalent. Okay, so when you are performing a natural join, you don't require the on keyword. And when you combine both of them, the final table that you'll get is C1, C2, C3, and C4. You'll get all the 4 columns because you have selected star here, right? So in a nutshell, join is a very simple concept which helps us combine data across multiple tables based on data in certain columns. Natural join works when we don't have to worry about the column names because the column names across 2 tables are exactly the same. Okay, and what we have learned till now, this concept is called an inner join. We'll learn what outer joins are and other types of joins in the next video.